Welcome back to another rigid body problem. The required tension in cable AB is 1200 newtons. Determine the vertical force P that must be applied to the pedal, and B, the corresponding reaction at pin C. All right, so it's a brake mechanism. You push P and the pedal, you create a tension in cable AB. Problems involving rigid body always start with free body diagram of your rigid body. In this case, the pedal. Step 2 is apply equations of equilibrium. We have 3 equations of equilibrium in 2D case. Summation of forces in x being 0, summation of forces in y being 0, and summation of moment about any point you want to pick also should be 0. So let's just start with free body diagram. Draw a free body diagram of this problem. You know it all by now. Step 1 is isolate and draw the outline of your rigid body. I'm drawing free body diagram of this foot pedal. And that's what I'm going to isolate and draw the outline of. And that's it. Step 1 is done. Step 2 is put all the active forces and moment in place. These are the forces that are trying to mess up the equilibrium. The only active force I see is force P that is not given to us. Step 3 is to find reactive forces. These are the forces that are trying to maintain the equilibrium and help the equilibrium. I've explained in previous examples too, this tension at cable AB, some take it as active, some take it as reactive. Doesn't matter when you add it to the diagram, as long as you don't forget about it and add it. So we're going to go do that. It's a tension, means it's going away. TAB. The value is given to be 1200 newtons. And then I have a reaction. This is a pin. Quickly figure out which way it is moving, which way it is not moving. It's a fixed pin, so it's not moving in X direction, it's not moving in Y direction, and it can rotate, yes. So these are a no, no, and a yes. Everywhere that you see a no, you got to add a force or a moment. In this case, I only see translation of no's. That means only on X and Y. So CX and CY. If you don't know which way they're going, that's all right. These are unknown, so you can definitely put them both in positive direction. So you don't have to mark the distances and all of that, but I have the habit of kind of completing my free body diagram a little bit, so you can absolutely do this. And this one is 125 mm. Step 1 is done. Perfect free body diagram. I don't think we missed anything. Let's move on to equations of equilibrium. The first one I'm going to use, which if you watch my videos, you know that this is what I like to do. I usually like to take the moment about the point where there are more unknowns, in this case CX and CY, because then I don't have to worry about those two right away. One equation and I can find my force P. So TAB multiplied by the distance of point C and line of action of this force, which is that 125 mm. I just converted to meters right away, divided by 1000. And this one is trying to rotate this way. It's with my sign, so that's positive. Next, I have CX, CY. They both pass through point C, don't create a moment. Next, I have P, and the distance between point C and line of action of P, the perpendicular distance is 300 or 0.3 meters. This is trying to go this way. That's against my sign. That's negative. This equals 0. TAB is given already to be 1200 newtons. So the only unknown I have is P. And you do the math, you can find P to be 500 newtons. I use one equation. I found one of my unknown. I have two more left. Let's use them and let's find the other two unknowns. Summation of forces in X should be 0. Start from one side, kind of make your way through. I have the tension, 1200 newtons, pointing to the left, so that's negative. Keep going. The next one I see is Cx, and that's pointing to the right, so that's positive. Keep moving. Cy and P both are in y direction, so I don't include them in this equation. Simple enough. One equation. Cx should be 1200 newtons. Last equation I have, summation of forces in y being 0. Again, make your way, start from left or right, make your way. TAB is horizontal, I don't include it. CX, horizontal, I don't include it. CY, and that's pointing up, so that's going to be plus. Keep going, then I get to force P, pointing down. It's negative. I already found P, so I can just write 500 newtons. As a result, my Cy is also going to be 500 newtons. So these are your answers, but we've seen in other problems too, it says reaction at C. So it's better to convert this into just one force. Let me see. Force Cx is 1200 newtons. Cy, about half of it, 500 newtons. This is what I'd like to find, C, and also find that angle. So magnitude of C, magnitude is 500 newtons. That's going to be squared. 1200 newtons. That's going to be squared. Square root of that. If you do the math, it would be 1300 newtons. Magnitude of C. Angle, I like to go with tangent usually, so it's 500 newtons over 1200. That is the tangent of that angle right there. As a result, you should get theta of 22.6 degrees. Can you take any other angle? Can you take this one? Absolutely. Can you take this one? Absolutely. Can you take this angle right here? Absolutely. So any angle you pick, as long as you clarify it and find the tangent, sine, cosine, use law of sine, law of cosine, find the angle, that is acceptable. As long as we have a magnitude and one of these angles, we can identify that force and that reaction, and that's good for us. Thank you very much.